So in this video, we're basically going to be talking a lot about Booleans, logical expressions, and a few other things that come along with that. So like I said in the second video, there are Booleans are a type of value in Python, and more specifically, there are two types of Booleans. There's true, and there's false. Now, as you might guess, true means true, and false means false, and that's pretty straightforward. But the question is, how do we use Booleans in Python? Like, what are they used for? So, usually we'll have variables describing events, like x is a variable that describes an event and y is a variable that describes an event. And I'll ask different things about these events. So like, for instance, what if I want to return true if both x is true and y is true? Then the expression that you want to use for that is x and y. Now, and is a logical operator in Python. So if I print x and y, then this expression is true only if x is true and y is true. So right now x is true but y is false, so this should print false. However, if I made y true, then it'll print out true because x and y are both. Now the other type of logical operator that we'll use is OR. This is if I want to say if x or y is true, then print true. So once again, this will return true if either x or y is true. Now, in this case, they're both true, so it'll print true. However, let's say that one of them is false. Now, even though y is false, because x is true, this statement is true. But if they're both equal to false, x is false and y is false, then that means x or y is false. Now, we can combine logical operators and make longer chains. For instance, I could have other variables like, let's say I have z and a, then I can say x or y or z or a. And this entire thing will be true if one of them is true. And let's say that I've and them together. Then this entire thing will be true if one of them, only if all of them are true. Now it gets kind of complicated if you do things like or. So you would only want to do that with parentheses, because otherwise you don't know exactly what's going to be evaluated first. So this statement would be true if x and y is true, or if z and a is true. Now, the next concept that you want to know about logical expressions is the concept of short-circuit evaluation. So let's say I had x, y, and z, and they all have some Boolean values, and I want to do x and y and z. Now, like I said, in order for this statement to be true, every single value, x, y, and z, has to be true. What that means is that the moment that one of the things is false, we know that the entire statement must be false. So in this situation, x is false, y is false, and z is true. So because we know x is false, the entire statement is false. So you want to think about it like this. Python is going to do as little work as it possibly can. And so as soon as one of the values is false, it just returns false. So for instance, if x was equal to true, then it'll look at x and be like, okay, it's true, so I need to keep looking. Then it'll look at y and say, oh, it's false, so just stop right there. Similarly, let's say that I do x or y or z. Now in this situation, it only requires that one of the values is true for the entire thing to be true. So once again, thinking in like the mind of Python being lazy, the moment it sees one true value, it just returns true. So if it sees x is true, then it doesn't even do any of this. Now the reason that this is really important will be made clear in a second when we talk about truthy and falsey values. Now it turns out that while using true and false is great, there are other types in Python, right? Like integers, floats, strings, and stuff like we haven't talked about. And every single value and type in Python has its own true or false value. For instance, let's say I said print true and 10. Now 10 isn't true or false, so it's not a Boolean, but it turns out that 10 also has a true or false value. And that's why we call it truthy or falsey, because it's not a Boolean, but it's still truthy or falsey. Now it turns out, so let's see what happens when I run this code. So it printed 10, so why would that happen? So what this means is essentially like I said, every value has a true or false value, But in order to know what's truthy and falsy, it's better to keep track of what's falsy. So all the things that are falsy are things that are like empty or zero. So 0 is a falsy value. The empty string is a falsy value. Empty lists are falsy values. And basically anything that's empty, including 0. So what that means is that everything else is truthy. So for instance, the number 1 is truthy. The number -1 is truthy. My name is truthy. Anything that isn't falsy will be evaluated and looked at as true in a logical statement. And it turns out, so in this situation, true is true and 10 is truthy. So both of these things have a true value, which means that this is a true statement. However, when Python, like I said in short circuit evaluation, Python does as much work as it needs to. And what it ends up doing is that the last value it looked at, it returns that. So it looked at true and it's like, okay, I need to keep looking to make sure everything else is true. Then it saw the 10 and it's like, okay, that's truthy. And so this entire statement is true. So I'll just return the last thing that I looked at, which is the 10. So that's why when I do this, it prints out 10. However, let's say that I did 0 and true. Now 0 is a falsy value, like I said. So if this is false and this is true, then this entire statement is false because not both of them are true. But Python won't even go here because the moment it sees a true value or a false value, it'll stop and it'll print out that value. So now it printed out 0. Similarly, let's say that I had 0 or the empty string or 0 divided by 7 or 5 or false. So this is falsy, this is falsy, 0 divided by 7 is going to evaluate to 0, which is also falsy, and then 5 is truthy. So the first thing that it sees is truthy is 5, and it knows that the entire statement is true, so it returns the 5. Now the reason we use short circuit evaluation is because it allows us to make sure that, it allows us to stop when we should. So for instance, let's say that we have some variable x and we have a variable y, and we're going to divide them. And let's say x is 5 and y is equal to 0. So we could just print x divided by y. However, if y is equal to 0, then obviously we don't want to do this because 5 divided by 0 is a 0 division error. So what we can do is say x must be equal to 0, y must not be equal to 0, and then we'll do this. So if y is not equal to 0, and if y is not equal to 0, then we'll do this. However, let's imagine that y is equal to 0. What that means is that this will return false. And so because of short circuit evaluation, this entire statement is false, so it won't even go here, which is good because when y is equal to 0, we don't want to do this division. So it'll return false. However, let's say y is equal to 2, then this will be true, and so it'll do this and return 2. So that's the basic intro to truthy and falsy values, logical expressions, and Booleans. And so that basically wraps up all the content for this week. And so look into the description below to see what the homework is. And you should be able to finish most of the homework just based off of the lectures that we had in class, today.